Firstly, this is not a debunking video. I am not debunking his arguments or his points. I am showing where he is being misleading, deceptive, dishonest, or outright wrong. I don't really trust channels that tout debunking or busted in their video titles or thumbnails. Both of those words have been absolutely dragged through the mud and are often used in conjunction with, well, lying. I also want to point out, my last video on Common Sense Skeptic was not very good, so please don't take it too seriously. I will probably go over why it wasn't good in a live stream sometime in the future, and I am also changing the title, thumbnail, and description of that video to reflect my opinion on it. As a general rule, I will mainly be focusing on his space-related videos. I don't really care at all about The Boring Company, Hyperloop, Neuralink, or even Tesla. First and foremost, I am a fan of spaceflight. SpaceX could have gone bankrupt years ago, and I wouldn't care. So long as rockets are flying, I'm interested in them. I don't give two hoots about Elon Musk or his other projects. Also, Common Sense Skeptic, you cannot in good faith call me a coattail rider, when if Elon Musk didn't exist, you would have a grand total of, let's see here, 7 videos. 7 videos out of your 73 videos are not about Elon Musk or an Elon Musk project.
We'll assume the persons selected to go will be healthy, fit adults with an average weight of 200 pounds. Nice easy number of 20,000 pounds or 10 tons, leaving 200,000 pounds of payload capacity. According to the website nasa.gov, astronauts aboard the ISS eat 3 very expensive meals per day, each weighing approximately 1.83 pounds.
He uses the cost of getting the meal to the ISS instead of the cost of the meal itself. The meal itself does not cost $18,000. That number is based on the cost per weight of the meal to the ISS on the Soyuz spacecraft. Yes, if you wanted to send 148,000 pounds of food to the ISS on the Soyuz spacecraft for whatever reason, it would cost you around $1.8 billion.
With 100 people eating 3 meals per day, weighing 1.83 pounds each, the expected transit expected to take up to 9 months, given the large size of the ship compared to Mars rover missions.
Here he uses the transit time of 270 days. That is just above the normal transit time for a Hautmann transfer. What he neglects to mention is that you can expend more delta V, that is, to burn more propellants, to reduce the transit time significantly. For example, if you can increase your velocity by 1 kilometer per second, it shortens your transit by 100 days. Obviously, there is a limit to how much you can do this practically. When you get to Mars, for example, you still need to be going slow enough to not melt when you hit the atmosphere. The rocket equation, or how much fuel you can bring with you, is probably the largest limiting factor. There is also the issue of diminishing returns. Increasing your velocity by another 1 kilometer per second won't decrease your transit time by another 100 days. So he is using both highly inflated food costs and inflated transfer times. Both of these add to his highly inflated conclusion. Now, I want to be clear, just because his conclusion is inflated doesn't mean that his conclusion is necessarily wrong. I've said this before and I'll say it again. In my opinion, Starship will never carry 100 people to Mars.
In the end, none of these calculations will likely need to be sorted out, since the machine itself has a built-in failure point that has escaped Musk and his engineers, and it's in the massive fuel tanks. Musk's demonstration slides for the tank design is rudimentary, of course, but shows a cylinder with convex ends holding the liquid oxygen. The aft end of that vessel extrudes into the tank holding pressurized methane gas. As a universal rule of thumb, heavy gauge pressurized vessels are cylindrical around their width, with rounded edges and no corners to minimize stress on any particular seam. The oxygen tank in Starship follows that guideline, but the methane tank does not. So when the tanks are at equal pressure, the methane is going to be forced into corners at the outside skin, trying to push its way out. If the methane tank is pressurized greater than the oxygen tank, it will want to buckle the dome under the pressure until both sides are equalized.
So here he talks about common bulkheads. These are not the egregious point of failure Common Sense Skeptic depicts them as. They have been used since the 1950s and were used on the very first American ICBM, the SM-65 Atlas. Some other rockets and rocket stages that have utilized common bulkheads are Falcon 9, Electron, Centaur 1, 2, 3, and 5, The Redstone rocket, Saturn V's S2 second stage, and the S4B third stage, ULA's Vulcan, Falcon 1, most of the Chinese Long March rockets, and the Ariane 5. By no means is this an extensive list. There are plenty more launch vehicles that use a common bulkhead. Now the Centaur upper stages are an important comparison here, because they are all made from the same stainless steel that Starship is, and those stages have been flying since the early 60s.
Now it's true that the Saturn V rockets, amongst others, had a similar design, with a rounded cell inserted at the bottom of another pressure chamber. So how did they manage to pull this off? It comes down to the materials in the sidewalls. Modern ULA boosters are constructed from thick aluminum plates that are milled into a diamond or grilled lattice, which provides structural support. The base material of this outer skin is roughly the width of a human thumb. It is friction stir welded along the entire seam, producing a joint that is indistinguishable from either piece. In this giant cylinder, there are only 4 such seams, creating what is, in effect, one solid piece of aluminum tube. But this is what Starship is made out of: sheets of 301 stainless steel, the width of a dime.
No. Starship is currently made from 4mm thick 301 stainless steel. A dime is 1.35mm, so what he should have said was about 3 times as thick as a dime. The upcoming Centaur 5 upper stage, however, is about 2/3 the thickness of a dime.
To get to ground level in the ship, crews would have to go through the pressurized propellant tanks, so they can't get there from the payload compartment. You know what else crew can't get to? The engine compartment. Any engine failure en route means Scotty is going to have to suit up for an EVA.
He is suggesting that you shouldn't need to go on an EVA to inspect the engines. How else would you inspect them? To have the engines in a pressurized compartment while the nozzles stick outside of it? The reality is that this feature is not compatible with the design of Starship, and would add extreme cost and complexity for little benefit. I want to be crystal clear here when I say that there has never been a spacecraft where you would have the ability to inspect the engines without an EVA.
And just to confirm, yes, the airlock is designed into the second lowest level of the pressurized area. It has direct access to the central vertical corridor of the ship, which may work fine when the vehicle is in space and not subject to gravity, but when the crew are climbing aboard on Earth and debarking on Mars, they will not be able to float between decks, and there doesn't seem to be an elevator in this diagram, or even a ladder.
That is correct, you can't float on Earth. How do you get from one floor to another? Well, what does your common sense tell you? They will have a ladder. That is the easiest and safest option. This point proves absolutely nothing.
Considering they will all be wearing bulky 280-pound spacesuits on and off this craft at either end, this would seem to be a major oversight.
A major oversight, he says. So his base statement is fine, right? If you had to wear those big Artemis-style EVA suits and climb down a ladder, that wouldn't really work, would it? So what's the easiest solution? Put the suits at the bottom of the ladder, right next to the airlock. That's what they do on the ISS. In the Quest Joint Airlock module, EVA suit storage is as close to the airlock as possible. In fact, on the Russian Poisk module, they actually store the suits inside the part of the airlock that gets depressurized and exposed to the vacuum of space.
The Exploration Extravehicular Mobility Unit, or the xEMU, will be the universal fashion while on the surface of Mars, or the Moon, or anywhere other than Earth. At a hefty 280 pounds apiece, those travelers who didn't keep up with their daily exercise regimen will definitely be feeling the burn after an hour or two in one of these fashion plates. Considering the condition Commander Scott Kelly was in after his time on the ISS, it will actually be a feat for any of them just to suit up.
This topic was actually more interesting than I expected. I couldn't find an additional source for this 280-pound figure. In future, I'm going to convert to kilograms because that's easier. So 280 pounds is about 127 kilograms. That number is closest to the weight of the Shuttle EMU, life support backpack and safer also included. The ISS EMU you'd think would be lighter due to improved technology, but actually it's heavier at 145 kgs. That's with safer and life support backpack included as well. What surprised me even more is that for the next generation Artemis xEMU, the mass limit, as of the HLS contract, is a staggering 177 kilograms. So, though he is still wrong, he is actually being generous to Starship here. Unintentionally, no doubt. NASA is obviously working hard to cut down on mass by a lot. That being said as well, mass on the moon does not matter as much to the astronauts as it would to astronauts on Mars. The current Artemis suits are obviously optimized for the moon. A suit with a mass of 177 kg would likely be far too heavy for Mars. Now, obviously the weight of the spacesuits on Earth doesn't matter too much to the astronauts. The suits will weigh 1/6 of that on the moon and 1/3 of that on Mars. The mass of the suits, however, does impact payload capacity. There is also a limit to how massive a suit can be so that a weakened astronaut can still use it after the months-long trip to Mars. That trip would never be equivalent to the 1 year of microgravity that Scott Kelly undertook, by the way. The Hautmann transfer, usually the most efficient in terms of fuel but often quite slow, usually has a transit time to Mars of about 9 months one way, and that is on the slower side. I will talk more about transit times later on.
Now that SpaceX has delivered a single two-man Crew Dragon to the International Space Station, 4 years behind schedule.
Boeing. In 2016, Boeing said that it would fly its first astronauts on Starliner in the year 2019. It is now 2022, and Starliner hasn't even docked to the ISS yet, let alone delivered any crew. And it charges 70% more than SpaceX does per seat. And it's been given $2 billion more than SpaceX for development. You cannot, in good faith, rag on SpaceX for wasting taxpayer money without ragging on Boeing, who has undeniably made worse use of that money than SpaceX has. It is also definitely worth mentioning that the reason both commercial crew providers are so behind schedule is that for years, commercial crew was underfunded by Congress. NASA could not get the money that they needed from Congress to pay Boeing and SpaceX to develop Starliner and Dragon fast enough. That being said, can you imagine the fit Common Sense Skeptic would have if the companies switched places?
The next point of concern is their projected travel time to Mars. On the SpaceX website, they are advertising they can get passengers to Mars in just 6 months, plus, of course, the time they spent in orbit around Earth. But this number seems unlikely, since every other craft that went to Mars took longer than this. Averaging out these 6 missions, you get a little over 9 months, not 6.
So a shorter transit time is completely in the realm of scientific possibility, and since he has made this video, the Perseverance rover completed its trip to Mars in about 7 months. In fact, the shortest dream speedrun time to Mars was the Mariner 7 orbiter, which took a speedy 128 days to get to Mars, which is about 4 months. That's less than half the time Common Sense Skeptic uses in his videos. So sure, if you cherry pick missions, you might get an average travel time of 9 months, but over all the Mars missions, there aren't all that many, mind you. The average transit time is about 7 months, not 9 months. There are outliers on either side, such as the previously mentioned Mariner 7, as well as the Viking 2 orbiter lander, which took 333 days, or about 2.5 times what it took Mariner 7 to get to Mars. But the fact is that the average transit time from all the previous missions is around 7 months, the fastest being only 4 months. And this doesn't just apply to Mars. It took Apollo 11 only 4 days to reach the moon, while it took Chang'e 4, one of China's lunar rovers, about a month to do the same thing. Robotic spacecraft aren't in any particular hurry to get to their destination. Humans, on the other hand, are. They would definitely be in more of a hurry to Mars than a robotic probe would be.
And that also happens to be the answer given by Wikipedia on the subject.
And again, he brings up the Hautmann transfer window, which usually is the type of orbit you would use to get to another orbiting body using the least amount of delta V required. But, like I've said before, you do not need to abide by the Hautmann transfer orbit. To me, this represents surface level understanding of orbital mechanics. Saying that this is concretely how long it has to take shows me that he doesn't really know what he's talking about.
Starship is a very large craft, especially compared to other vessels that have traveled to Mars. If you want to go faster, you have to not only have the fuel to speed it up when it leaves, you also need to have at least that much fuel again to slow it down before arriving.
No, you don't necessarily. You would need about the same amount of delta V to capture into a low Mars orbit if you didn't use aerobraking. But the mission profile of Starship in its current form is not to perform a capture burn. Starship's transfer from Earth would be so that it directly enters the Martian atmosphere, which it will use to shed nearly all of its velocity prior to landing. This is effectively the same profile as the Perseverance rover, as well as the vast majority of other rovers and landers that have been sent to Mars. Only a couple of them performed capture burns. The most recent example was the Tianwen-1 mission, which was a combined orbiter and rover mission. That being said, orbiters are not used for larger spacecraft such as Perseverance, Curiosity, the Phoenix lander, and even the twin rovers Opportunity and Spirit. None of these missions made a burn to capture into Mars orbit. If you don't have an orbiter, a capture burn is just a pure waste of delta V. Also, it's worth mentioning that the Hautmann transfer delta V requirement can change dramatically depending on the year that you are launching in. This is due to the alignment of Earth and Mars.
The safest rockets come in at around 90% mission success. That stat includes the SpaceX Falcon 9, credit where it's due, although the recovery rate is significantly lower.
A Falcon 9 V1.2, right, so that was a much earlier block design of Falcon 9. The Block 5 variant, which is the most recent and is the only version of Falcon 9 to be human rated, has never failed during launch. And of the 75 landing attempts at the time of writing, only 4 Block 5 boosters have failed that landing attempt. So, for Falcon 9 Block 5, that is a mission success rate of 100% and a booster landing success rate of about 95%.
The best on the market was the Delta II at 98% before it was retired.
So again, this isn't really true. If you're not counting different block versions, Atlas V is probably the most reliable. Out of 90 launches, the one partial failure the vehicle had was corrected by the payload's propulsion system. If we're talking mission success rate, Atlas V is the most reliable with a 100% mission success rate. And if you want to count Falcon 9 Block 5 as its own rocket, then it would be tied with Atlas V at a 100% success rate.
With spaceflight, there will eventually be a vehicle failure, and if the agency is lucky, it's only 2% of the time.
If the agency is lucky, it's never, just as it has been with Falcon 9 Block 5, just as it has been with Atlas V.
The latest rover delivery system, such as the one deploying from Earth later this summer to deliver Perseverance, interfaces with the atmosphere, which is too thin for aerobraking but thick enough to cause heating.
Too thin for aerobraking. That is unequivocally false. Orbiters can and have utilized aerobraking, and they only just touch the outer edge of the Martian atmosphere. He needs to be careful of his phrasing here. What I think he means when he says too thin for aerobraking is that for soft landings, a purely atmospheric landing isn't possible. So that means you cannot really make a parachute big enough to slow a spacecraft down enough to land safely without rocket propulsion. That is true of every single soft lander on Mars, by the way. All of them use some form of retropropulsion. The reality is that Starship will bleed the vast majority of its velocity via atmospheric drag. The design of Starship allows for the creation of lift, enough even to gain altitude in the Martian atmosphere. This allows it to spend even more time shedding velocity in the atmosphere at speeds where all previous vehicles have needed to deploy supersonic parachutes because they could not generate enough lift to gain altitude. This is an old simulation, but it still shows what I'm talking about here.
It is up to retro rockets to lower it most of the way to the ground, and that's when a 4-point sky crane lowers it gently to the surface in an ideal spot. The biggest reason for the retro rocket crane is to avoid blasting a crater into the very fine, toxic, abrasive regolith.
This is not entirely true. That is not the only reason they chose to go for a sky crane. To have the landing engines under the rover, you would then have to worry about a ramp system and a landing leg system. One other primary reason for the lack of a main parachute and airbag system, like the previous Spirit and Opportunity rovers, is because Curiosity and its twin Perseverance rover were simply too heavy to not have a significant form of propulsion in their respective descent processes.
In this simulation description, while the two are connected tail to tail, Starship somehow slows its velocity enough while in orbit to cause the fuel in the tanker to flood forward into the Starship holds, which is a neat trick, since both vehicles' main engines are being blocked by the other vehicle, leaving only small maneuvering thrusters in the nose to possibly force the ship backwards hard enough to cause the payload to slosh forward.
Reaction control thrusters have been used for the purpose of pushing propellant to one end of the spacecraft since the 60s. They do provide sufficient thrust for this purpose. Again, this screams surface level understanding to me. This is an excerpt from a document from United Launch Alliance on the topic of realistic near-term propellant depots. Link is in the description. Research for cryogenic upper stages dating back to the Saturn S4B and Centaur found that providing a slight acceleration, as little as 10 to the power of -4 to 10 to the power of -5 5g of acceleration to the tank can make the propellant assume a desired configuration, which allows many of the main cryogenic fuel handling tasks to be performed in a similar fashion to terrestrial operations. The simplest and most mature settling technique is to apply thrust to the spacecraft, forcing the liquid to settle against one end of the tank. The thrust can come either from small rockets or from venting a small amount of boiled off propellant gas through small nozzles, and can be applied periodically or continuously.
Which brings up a point to quickly touch on. Vehicles in LEO have a mean orbital velocity of about 17,000 miles per hour or 28,000 kilometers per hour. If the vehicle slows down significantly, its orbit will degrade. Just as if it speeds up, it will climb further away from Earth into a higher orbit until it leaves LEO. How do they expect to slam on the brakes and maintain their velocity and orbit?
When you say slam on the brakes, do you mean burn retrograde? And why could you not flip the ships and burn prograde afterwards, or even before you started refueling? How about burning normal or anti-normal to just change the orbital inclination?
It actually doesn't seem to be a very feasible concept at all, especially since the fuel they would be transferring would be in the payload compartment, not the main propellant tanks as shown in the demo.
Plumbing. In fact, plumbing going from the very top of the ship to the very bottom already exists in the form of the large downcomers which deliver oxidizer from the top of the header tank to the engine.
See, most large tanks made for hauling liquids contain baffles to minimize slosh in the tank while in motion. This includes most other spacefaring vehicles. For example, the large lightweight external tank on the space shuttle, a vessel similar in diameter to Super Heavy, had anti-slosh baffles. So does the Saturn V launch booster. These are meant to prevent the liquids from relocating in the tank quicker than the control systems on the rocket can compensate for the motion of the liquid as it affects the center of gravity on the craft.
Starship does have slosh baffles.
Musk is continuously going on and on about how the Starship program is going to take full advantage of rapidly reusable rockets, but there's definitely a bit of a gap in the logic. First, if the Starship itself is going to be going to Mars and staying with the people that brought there, that's not a reusable craft.
It does come back from Mars. It refuels using in-situ resource utilization and returns to Earth. The fact he included this point is just plain bizarre to me. In-situ resource utilization is also already being tested on the Perseverance rover.
This still frame from their launch video shows how SpaceX intends to land Super Heavy, one of the largest boosters ever made, right back onto its own landing mounts, while a fully fueled tanker sits just a couple hundred yards away.
This still frame of a render is a concept of one of the old BFR systems, mind you, which shows the tanker Starship waiting on the ground right next to the launch tower and booster. Now, obviously, this is just a render, and obviously keeping a fully fueled tanker full of methane and oxygen right next to a rocket launch is not a good idea. Propellant loading is always done after the rocket is fully stacked and on the pad. So if you were rational, you would think, hey, this is just a render. There is no way in hell they would be stupid enough to actually use this launch and restacking profile. It's just way too risky. But instead, if you're Common Sense Skeptic, you assume that this is how they are actually going to do things.
Since we don't know how much fuel will still be on board when it lands, we'll run the numbers as if the vehicle explodes on the launch pad during a takeoff, and that'll cover both scenarios.
That doesn't cover both scenarios. In the landing scenario, the booster will be almost completely empty. And again, if they were smarter than a 5th grader, they wouldn't have a fully fueled tanker right next to a landing rocket.
Let's put the efficiency of this entire refueling concept into terms that is dead easy to understand. If the trucking industry worked on this same premise, the driver of this truck would be using everything in the big tank to deliver the contents of the small one.
This applies to all conventional orbital rocketry. It is the tyranny of the rocket equation. On average, at launch, fuel makes up 90% of the total weight of the rocket. This is not just an efficiency problem with the refueling system. It is an efficiency problem for every single chemical rocket, inherent with the rocket equation. Bear in mind as well, the fuel in the truck is far less expensive than the truck itself. In this comparison, all conventional fuel deliveries would throw the truck away after the fuel, the payload, was delivered. What SpaceX is doing is trying to reuse the truck. Now obviously this is just a comparison. A truck is nowhere near as complex or as hard to reuse as an orbital class rocket,
resulting in an explosion that threw shrapnel for hundreds of yards and destroyed the Cape Canaveral's Launch Pad 40, which required 15 months to rehabilitate. Looking at the Dragon 9,
his diagram claims that Starship Super Heavy carries 4,600 tons of fuel and that Falcon 9 carries 112 tons. Ignoring his confusion between US tons and metric tons, he's also confusing fuel for propellant. This is something he does frequently, seemingly not understanding that rockets carry both fuel and oxidizer. He also gives a figure of just 112 tons of propellant for Falcon 9, which actually carries 520 tons of propellant. This obvious mistake throws off his calculations by a factor of 4.6. It's worth pointing out that Common Sense Skeptic claims to be working with a team. It's never, "this is my opinion," or "I think this." It's always, "this is our opinion, and we think this." Again, where was his team of fact-checkers?
For reference, ammonium nitrate has an energy density of 1.4 megajoules per kilogram and a detonation velocity of 2,550 meters per second. Methane gas has an energy density of 55.6 megajoules per kilogram and a detonation velocity of 1,800 meters per second. And unlike nuclear weapons, which only release 50% of their energy as blast, with 35% released as heat and 15% released as radiation, 100% of conventional explosives go into creating the blast, which will make for some very interesting fireworks during Starship's eventual and inevitable rapid unscheduled disassembly.
Why bring up the percentage of energy that goes into the blast for conventional explosives when you are comparing nuclear explosives to a methane explosion of Starship? Neither of those are conventional explosives. How much energy in a methane explosion is converted to heat energy? How much is converted into light energy?
Comparing this wireframe diagram to one of the latest renders of Starship, we can see it's a fairly close match. As a quick side note, some people on various chat feeds have declared that we have the LOX and the CH4 tanks backwards, and that it is the cryogenic methane tank that occupies the upper chamber. As you can see from this SpaceX slide, that is not how it's presented, and really it makes sense to have the LOX closest to the living area should they happen to need extra oxygen in the cab.
Couple of things here. Firstly, the methane tank is the one on the top. Not only has that been confirmed a long time ago via eagle-eyed tank watchers who snapped pictures of the labels that SpaceX put on the tanks during construction, but it is also obvious that the render he's showing on the right hand side is extremely outdated. The winglet shape is very different to the current design, and the header tanks are also in completely different positions than they are in the current design. All of that aside, we know for a fact that the smaller tank on top is the methane one, because as a rule of thumb with rockets, with the exception of hydrogen-fueled rockets, because hydrogen is far less dense than kerosene or methane, you need far more oxidizer than fuel. Here are some diagrams. Once again, this screams surface level understanding. In regards to the liquid oxygen tank being close to the pressurized area for the purpose of giving more oxygen to the crew in case of emergency, well, I'll just play this clip from one of my old videos.
And really, it makes sense to have the LOX closest to the living area should they happen to need extra oxygen in the cab.
Oh no, what if they need more oxygen in the cabin? If only there was a tank of liquid oxygen at the very top of the spacecraft, right next to the pressurized area. They really should have thought about that one.
According to the May 2019 article on DuQuark.com, studies indicate that to reduce the radiation exposure by GCRs by half, they would require a water reservoir 2 meters thick surrounding the entire compartment.
Currently, the best known method of dealing with GCRs is to spend as little time as possible in contact with them. That means you do as much shielding as you can to an extent. If halving the amount of GCRs that reach you means adding 2 meters of liquid water to your spacecraft, maybe you should look into ways to cut your transit time in half, rather than focusing on shielding, which with the technology we have at the moment is inefficient for GCRs. Obviously, still, shield as much as you can. Even with minimal shielding, you should still have the radiation budget for a maximum 4-year round trip. That conclusion is based on a UCLA research paper, which I've linked in the description. Once you get to the surface of Mars, then you can just use regolith as a radiation shield, likely combined with normal deep space grade radiation shielding on the hull of the habitation module. That should be reasonably effective against both solar radiation and galactic cosmic rays.
Some things to keep in mind while we are reviewing this footage from the SpaceX live feed. This is not a Starship prototype. It's a test article, one that was only partially fueled with nothing at all in the nose cone.
Okay, this is an argument of semantics. Generally speaking, test articles, proof of concepts, and prototypes are all usually considered synonymous.
So what happened? Slowing the footage down at 1 minute 40, there is an unknown material break away from the Raptor engine in the top left-hand corner. After this is burned away, it takes only frames of video for that Raptor engine to flame out, and this causes a wash of flames inside the compartment that burns off the silver linings on the components in the top right of the picture. Those flames and those materials disappear in seconds, but an unknown something in the bottom left of the frame continues to burn for several minutes.
That is not smoke, that is venting of cryogenic propellants. Smoke would leave a trail in the air, this stuff disappears completely.
This smoke was noticed by observers at the time, but was later dismissed as simply the first Raptor engine being cut off.
Again, that is a white cloud from vented cryogenic propellants, not smoke. Notice how it is very consistent and from a very small point. There is also a short burst of a larger vent, followed by another vent firing about halfway up the vehicle.
At 6 minutes 30, the three Raptors try to reignite to gimbal the craft back into a vertical configuration.
On SN8, the intention was for only 2 Raptors to be lit, not 3 as he stated here.
It's hard to tell from this angle if the lower Raptor came back on, but the upper 2 fire and begin to gimbal wildly to swing the craft around. The first obvious indication something is happening to the left-hand Raptor comes at 6:33, when tiny particles are caught in the flame. Shortly afterwards, a flicker of green is first seen in that flame, and then another, and more, until eventually the entire flame becomes a very bright green.
You shouldn't really say flame here, the proper term would be plume or even exhaust.
But what we noticed from the available footage is this. Remember way back in episode 1, where we were concerned that the common bulkhead between the methane and the LOX tanks would create a weakness in the ship? We took a lot of heat for that, especially from the Musk fanboys who have found the episode since, and they've dragged that episode down to our lowest approval rating of all episodes. So we found it very interesting that when SN8 impacted the ground, the vehicle did indeed split, and it split right at the level of the tank's common header. You can see 2 frames after impact with the ground that the LOX in the upper vessel has escaped the vehicle through the sides in a white cloud.
This goes back to my previous point. A common bulkhead is a point of failure. But to be honest, in this situation, it wouldn't matter if it had no common bulkhead. The tank still would have failed. That doesn't change the fact that common bulkheads are extremely well understood and have been used since the 1950s at least in the SM-65 Atlas ICBM. Side note, the Mercury Redstone rocket also used a common bulkhead, but the diagrams for the original ICBM are a little bit less clear.
That throws shrapnel across the site, and the fireball it created is completely gone 6 seconds after detonation. This confirms our theory about how the craft will suffer catastrophic failures as brought up in episode 5 and again in episode 7.
But you said yourself, this was a test article, not even a proof of concept, but somehow it proves your point about how the finished product will suffer catastrophic failures as you brought up in previous episodes. You can't have your cake and eat it too.
One thing is for certain, if this is the landing procedure they are planning on using for the colonists that they're taking to Mars, that's going to be a rough ride. Belly flopping through Earth's atmosphere will break far more velocity off the craft than diving through Mars's very fractional atmosphere. The flaps of the vehicle in that atmosphere will pretty much be useless.
No, the Martian atmosphere will still provide Starship with enough control authority to control its entry, generate more or less lift depending on circumstance, and to generally be fairly accurate in terms of its landing site. Remember, most of the force for the flip action actually comes from the gimbaling engines. The force from the gimbaling engines, combined with the aero surfaces, combined with the hot gas thrusters, will be more than sufficient to flip the ship around. You'll notice on the SN8 footage, the aero surfaces only start moving after the engines ignite.
And swinging the vehicle like that from side to side to land upright at the last second will slosh methane, LOX, water, and everything else in the payload bay from side to side, resulting in far more momentum that the upper thrusters will have to offset to come anywhere near landing upright.
Slosh is dealt with in a couple of ways. Firstly, the header tanks will be almost entirely full, meaning slosh won't matter for these tanks. The main tanks utilize slosh baffles, especially at the bottom of the tanks near the plumbing that takes the propellants to the engines. The upper reaction control thrusters are barely used. The gimbal authority from the Raptor engines negates most of the need for these thrusters to be used after the engines have ignited. Once more, the lack of understanding about the power of gimbal authority screams surface level understanding.
Starship needs to stow away every calorie the traveler will need while on this excursion, and don't count on other supply vessels waiting on the surface with fresh supplies either. Anything sent ahead of time sitting on Mars' surface will be freezer burnt, irradiated, and almost certainly spoiled. As a point of fact, food supplies on the ISS have a shelf life of 12 months, or less than half the time between home and transfer orbits between Earth and Mars.
ISS food packets are not designed to last more than a year. That is because the station is resupplied once every few months. Food packets don't need to have a shelf life longer than a year. That does not mean that you can't manufacture food packets to last longer than that. Most MREs have a shelf life of 3 to 5 years, and there's nothing to suggest that NASA couldn't engineer their own food to match or even beat that shelf life if they needed to.
And how the hell a giant cigar tube with no extendable legs is supposed to land upright in an uneven field of talcum powder?
It will have legs. There is no reason why they wouldn't have legs.
It is actually a little disturbing what the FAA considered to be acceptable environmental losses to facilitate this launch complex. In that recommendation, SpaceX had certain responsibilities with regards to the safekeeping of the area, most of which they have reportedly failed to live up to. As stated in the very title of this recommendation, this assessment was based upon launches of Falcon 9 and Falcon Heavy vehicles, including unnamed reusable suborbital launch vehicles. Nowhere in this paper is the Starship mentioned.
The Starship prototypes, or whatever you want to call them, can be and are classified as, quote, a variety of reusable suborbital launch vehicles. They fall under that description.
And not a single Dragon vehicle has ever been launched from Boca Chica.
Not a single Dragon vehicle has ever been launched from Boca Chica, where he obviously means to say that not a single Falcon 9 has been launched from Boca Chica, since the FAA Environment Assessment does not mention the Dragon spacecraft at all.
And one last thing about Boca Chica before we sign off, although it's a complete long shot. If it happens, it really could affect the launch site of Boca Chica. Lawmakers in Texas, fed up with federal government shenanigans, plan to introduce legislation calling for a referendum on secession of Texas from the United States. And while many would instantly dismiss such a thought, nobody thought Brexit would actually happen either. During the flip maneuver on landing, although 3 engines fired up, 2 of them had shut down again before landing, and one of those had ruptured a methane line, causing orange fire to wash up the vehicle as it landed.
The 2 engines shutting down is intentional. The plan was, at that point, to ignite all 3 engines and pick the best 1 or 2 to land on and shut down the others.
When it landed, the vehicle bounced off the ground because the landing legs that SpaceX installed are ridiculously useless. In fact, 3 of them were swinging in the wind as it landed and came to rest with a leaning angle.
So, no. It bounced off the ground because the Raptor engine was underperforming significantly, and it didn't slow down nearly enough. Even if it had better legs, the speed at which it landed, about 10 meters per second, would likely have been over the tolerances of the legs.
That fire continued in the skirt, eventually erupting out the side of the craft and launching it a second time. Now check this frame out from just before the eruption. The first indication this was going to end poorly is a deformation in the nose cone, right here, as the bottom portion of the rocket was forced upwards from the explosion. Then the bottom portion of the craft tore apart like paper as the methane tank above it ruptured. Except that's not the methane tank, is it? That's the LOX tank. The methane tank is supposed to be the higher tank, by all accounts.
Is it the LOX tank? Because you seem awfully confused about that, and have never corrected yourself or even addressed the fact that you got it wrong, by all accounts. Not by yours.
As a quick side note, some people on various chat feeds have declared that we have the LOX and the CH4 tanks backwards, and that it is the cryogenic methane tank that occupies the upper chamber. As you can see from this SpaceX slide, that is not how it's presented. Then the bottom portion of the craft tore apart like paper as the methane tank above it ruptured. Except that's not the methane tank, is it? That's the LOX tank. The methane tank is supposed to be the higher tank, by all accounts. And remember the deformation in the nose cone? How exactly are the engineers at SpaceX expecting that structure to hold up when this vehicle is approaching max Q? Without additional support, that's going to rip right off the vehicle and send whatever or whoever is in it back to Earth much quicker than expected.
So SN10 was never designed to break the speed of sound. If it was never designed to do that, why would they bother adding additional structural support to the nose cone if it was unnecessary in this case? At this point in time, SpaceX was trying to prove that the landing could be done, not that it could survive max Q on a fully stacked Super Heavy booster.
For the foreseeable future, Starship is nowhere near ready to deliver such payloads to orbit. And while we're showing this frame, let's just acknowledge that this has to be the dumbest configuration for a deployment bay ever. Single hinge point on a rounded surface, no clear exit for your payload, no robotic arm, those satellites are going to bounce off of everything and probably smack that front door open permanently.
Yes, that is why the payload door design has changed since then. In the new design, they open down the middle in a similar fashion to the Space Shuttle payload doors, which, structurally speaking, is much better than the previous design.
No Starlink devices have been delivered to orbit using a Falcon Heavy. Wonder why that is, since it's apparently a functional system with a far greater payload capacity.
The reason for that is very, very simple. The stack of Starlink satellites is limited by fairing volume much more than it is limited by payload capacity. The Falcon Heavy has a far higher payload capacity, but has the same sized fairing that the Falcon 9 does. It has nothing to do with whether or not Falcon Heavy is, quote, functional or not. That doesn't change its fairing volume.
Yet to date, the only things it's launched into space were the Roadster that Musk stole from Martin Eberhard in 2018, the Arabsat 6A mission in April of 2019, and a DoD mission the same June. Dragon Heavy hasn't flown for over 2 years.
Dragon Heavy, he even wrote it on the fucking text in the video. Surface level understanding.
700 launches later, that simple math totals $38.5 billion, just for the launch vehicles. The satellites have a reported aspirational cost of $250,000 per unit. Again, that's an aspirational target for the manufacturing cost, not the cost to date, which has been reported to be as high as $500,000 per unit.
God, that's interesting. Why is there a big empty space after those words in the article headline? Yet look, there's a big space between the words of the title and the words of the date and the author's name. Oh, well, I'm sure it's nothing. Oh! That would explain why you left it out. If a Falcon 9 cost only $30 million per launch internally, then 700 launches would only cost $21 billion. That's a pretty significant difference. So why did you use this article as a source for the cost of the Starlink satellite, but not the cost of launching the Falcon 9? If you omitted this information from your numbers for a good reason, then why did you erase that part of the title? Surely, if you omitted them for a good reason, you could easily explain why you weren't using the $30 million number. The more likely explanation for this is that the internal $30 million per launch number didn't fit your narrative. So you erased it and then replaced it with a number that did.
And remember, we use the conservative estimates on all these numbers. If the satellite costs are $500,000 per.
Cost per Dragon 9, what? You wrote it twice as well. Also, no. Again, SpaceX charges the customer $50 million because SpaceX is a private company and they need to turn a profit. That does not represent the internal cost for a Falcon 9 launch. SpaceX is not going to charge a customer $50 million if they didn't turn a profit on that launch. The $30 million figure actually appears to be a decent ballpark for what a Falcon 9 launch costs SpaceX internally. To reiterate, a conservative estimate would not use the customer price for a Falcon 9 launch. That is ridiculous.
The Falcon 9 has a noise rating of 131.4 decibels inside the fairing, a result of the 1.7 million pounds of thrust it produces. In comparison, the Saturn V was measured at up to 220 decibels at the launch site, a result of the 7.6 million pounds of thrust it produces. And the Super Heavy booster is expected to produce twice the power of a Saturn V, with over 16 million pounds of thrust, potentially doubling the volume of a Saturn V vehicle launch. But this level of energy is not experienced as noise. Above 194 decibels, sound is converted into a shockwave, and that shockwave will kill every living thing in the direct vicinity of the launch pad, and blast the eardrums out of every creature until that shockwave drops below 140 decibels. The destruction of hearing in an animal is often a fatal injury. The Falcon 9 at 131.4 decibels was always below the permanent hearing damage threshold. The Super Heavy at a possible 230 decibels would be 1,000 times greater. So the entire Appendix B of this document regarding the effects of noise referred to throughout this document is sheer unmitigated nonsense, since they use 150 decibels as the SPL in the immediate area of the launch site on their diagrams on page 11 of Appendix B. KBR has embarrassed themselves in this assessment by ignoring such obvious historical parallels using other known launch platforms, i.e. the Saturn V and Space Shuttle launches. Assuming their modeling is correct and their numbers were just low, we can swap out the 150 decibels they used with the known 220 decibels of a Saturn V launch and demonstrate that South Padre Island can expect to be blasted with 180 to 190 decibels of sonic energy, and every living thing in the Boca Chica area will be deafened or destroyed.
Okay, to understand what he has done horribly wrong here, we have to understand a few concepts about sound. The SWL, or sound power level, is what you would expect to receive if you stood at the source of the sound. So the SWL of the Saturn V, according to Common Sense Skeptic, was about 220 decibels, which isn't correct. The 220 decibel figure he uses comes from an unsourced website. The actual SWL figure, as cited by NASA, is about 204 decibels. So if you were standing in or next to the nozzles of 5 F1 engines, you would experience about 204 decibels at launch. Briefly, before you were turned into jelly and incinerated, of course. You might think when looking at this map that KBR is trying to pass the 150 decibel figure as the SWL of a Starship orbital launch at ground zero, right next to the engines. But as we can tell from the key in the bottom left, that is not the case. The 150 decibel figure is for the half-mile to a mile diameter red inner circle. Where Common Sense Skeptic went wrong is he is assuming that inside this red circle, the sound experienced would be 220 decibels. Remember, that is the sound power level right next to the engines of the Saturn V, experienced over the entire area of this circle, which covers the entire launch facility. He thinks all of that half-mile diameter circle would experience the same level of sound as if it were right next to the engines of the Saturn V at liftoff. His fatal mistake here is mixing up sound power level, which is SWL, and sound pressure level, which is SPL. Sound power level is the absolute level at the source. It's not adjusted and can't be adjusted for distance. Sound pressure level is a measurement of the pressure of that noise through a medium at a distance. The map he is using on page 11 is for unweighted sound pressure levels. There is no such thing as a sound power level distance map, since sound power levels can only be determined at the source of the sound. So basically, Common Sense Skeptic didn't like the numbers that KBR calculated with, so he wrongly inflated them to fit his narrative. The report concludes that the easternmost parts of Brownsville, which is about 19 miles from the launch pad, would experience a maximum of 111 decibels from an orbital launch. They also calculated that per exposure, so per launch, one damage claim per 1,000 households would result from the exposure to 111 decibels. Another thing he gets wrong here and on Twitter is the decibel figure for the Falcon 9 launch. Falcon 9 sound levels were measured at 134 decibels inside of the payload fairing. That's right, inside the sound-controlled payload fairings, which are about as far away from the engines as you can get on the rocket. He then uses this number as the sound power level at launch. Remember, the sound power level is taken at the source of the sound, the engines.
The Falcon 9 has a noise rating of 131.4 decibels inside the fairing, a result of the 1.7 million pounds of thrust it produces. In comparison, the Saturn V was measured at up to 220 decibels at the launch site, a result of the 7.6 million pounds of thrust it produces. And the Super Heavy booster is expected to produce twice the power of a Saturn V, with over 16 million pounds of thrust, potentially doubling the volume of a Saturn V vehicle launch.
Someone on Twitter correctly points this out to him, and apparently he thinks the 134 decibel reading inside the fairing is pretty much the same as standing under the engines.
These are demonstrable facts.
These are demonstrable facts. No, they aren't. You are just lying. You are making things up to fit your narrative.
The new NASA spacesuits headed to the Moon and Mars are called the xEMU, but that technology is proprietary to NASA and wouldn't likely be shared with SpaceX. These multi-million-dollar suits are custom-built per traveler.
That is not true. The xEMU suit is a one-size-fits-all spacesuit. Unlike the ISS EMU, the suits are not custom-built per traveler. They are a universal, standardized size. One thing that might not be universal is gloves, but again, gloves are a whole lot cheaper to do than a whole spacesuit.
Even if the lowball number Angry uses is accurate, based on the N1 yield as a full-tank detonation of Starship, it could hit 14 kilotons. The yield from Little Boy was 15 kilotons, so that's pretty much even money. But if the yield estimates up to 7 kilotons for the M1 explosion are more accurate, that number jumps to 7 times 2, or up to 98 kilotons. The actual number is probably somewhere in the lower middle, mid-20s for a full-out RUD consuming all tanks simultaneously.
Tell me, how would all of the fuel and oxidizer be mixed and then detonate simultaneously? Also, your numbers here are incorrect. Yes, Starship carries twice the tonnage of propellant, however, this does not account for the significantly lower density of liquid methane than RP-1, which is what the N-1 used as propellant. That directly affects what percentage of the propellant is oxidizer and what percentage is fuel. RP-1 is far more dense than liquid methane, meaning it requires far more liquid oxygen in order to achieve the ideal combustion mixture in the engines. I will go into a lot more depth about this point later on in the video.
Mars was once covered in water, and that water did not all bleed off into space.
Being covered in water in the past doesn't make something habitable now.
Living organisms in the Dead Sea, zero. No. Not only is there life in the Dead Sea, but we also find life almost everywhere we look for it on Earth. Kilometers underground, kilometers underwater, kilometers in the air. Every extreme environment you can think of on Earth, we find life.
Everest is a beautiful but horrifying place with extremely powerful winds, as you can see here, that would blow away any habitat you tried to put on top of it.
Well, it seems that most people that travel to the Himalayas to climb to the summit of Everest bring little more than a pup tent, so that argument dies pretty quick.
That is at Everest Base Camp. Angry Astronaut is talking about the summit of Everest. That is an altitude difference of about 4,000 meters. The summit of Everest is at the same elevation where the jet stream usually is. So, quote, winds during much of the year exceed 128 kilometers per hour. The average wind speed at base camp, where this picture was taken during the windiest months, is about 22 kilometers per hour.
Trillions upon trillions of tons of water ice remain just below the surface, all over the planet.
Every expert has their own assessment of the amount of water left on Mars, and digging for it has not yielded great results.
That being said, all the experts agree. There is water ice trapped in the Martian permafrost. Here is some highly pure water ice that was exposed in a recent impact crater in 2008. Here is some subsurface water ice exposed by the Phoenix lander. While the solar wind had a role in the disappearance of water on Mars, the water, largely, didn't escape via solar wind. Quote, a part of the liquid water inventory sublimed and was transported to the poles, where the rest became trapped in a subsurface cryosphere. That is not just a theory.
A game theory!
That has been confirmed by water-equivalent hydrogen scans of Mars.
If you don't have adequate protection from the Martian atmosphere, you're dead. You know what happens if people step outside of their shelter on Everest? Nothing.
Not at the summit of Everest. If you were around sea level and were somehow teleported to the top of Everest, you would likely pass out within seconds and you would die within minutes to hours due to hypoxia.
Around this time, Angry mentions how all of the windows in the Martia and the giant overhead skylight will have circulating water flowing through them to maximize radiation protection. And there's so many things wrong with that. First off, a skim coat of water, whether it's circulating or not, is going to provide almost no protection against radiation.
That is not true. As a blanket statement, you cannot say a skim coat of water is going to provide almost no protection against radiation, because water is very good at stopping solar energetic particles, but not so much GCRs, which are much harder to shield from. You need to specify what type of radiation you're talking about.
So although the suit looks pretty, especially given the blonde model that Newman squeezed into it, further, as with the ISS, the vehicle would require a large array of radiators for cooling the interior of the ship, and those don't seem to be accounted for.
Starship likely doesn't need radiators anywhere near as large as the ISS. The ISS is a unique case because it has a very large surface area exposed to the sun all at once, and a decent amount of energy is bounced back off of the atmosphere towards the station.
But all these departments would have to be covered, amongst others.
Engine compartment. Come on, dude, come on. You can do better.
Since we don't know how much fuel will still be on board when it lands, we'll run the numbers as if the vehicle explodes on the launch pad during a takeoff, and that'll cover both scenarios. The Starship carries 1,200 tons of propellant. The Super Heavy carries another 3,400 tons. A tanker would have another 100 tons in the payload compartment, but we'll run this as if it's a crewed mission. And then, we're going to compare the results against the nuclear bomb that took out Hiroshima. 4,600 tons of propellant is 4.6 million kilos. According to EPA.gov, 4.6 million kilos of methane contains 255 billion BTUs of energy. 255 billion BTUs equates to 64 kilotons of TNT. And the nuclear bomb that wiped Hiroshima off the map was a 15 kiloton device. So, super heavy, fully loaded with the Starship, is equal in potential energy to about 4 Hiroshimas. The Starship carries 1,200 tons of propellant. The Super Heavy carries another 3,400 tons.
So, Starship has 4,600 tons of propellant in total. As of the SpaceX website, that is correct. However, these numbers will be the last thing he gets right in this segment. In rocketry, when we say propellant, we mean oxidizer and fuel. If you're only talking about one of those, you specify which one you are talking about. So, the fuel in this case is just the methane. The total propellant load of 4,600 tons includes both methane and oxygen. So, not just methane, as he is asserting in his calculations. Nitpick here, but BTUs are kind of a weird unit to use. The usual measurement for energy calculations would be joules. But anyway, so to figure out how much of that 4,600 ton propellant figure is methane, we first need to know how methane and oxygen burn. So methane burns as follows. 2 O2 molecules plus 1 CH4 molecule turn into 1 CO2 molecule plus 2 H2O molecules. The atmospheric mass of oxygen gas is 16, carbon is 12, and hydrogen is 1. So 2 times 2 times 16 equals 64 mass units of oxygen per 12 plus 4, 16 atomic mass units of methane. That makes it a 4-to-1 ratio of oxygen to methane. So that is for a perfect stoichiometric ratio, but the Raptor engines fire in a slightly fuel-rich combustion mixture. According to the FAA, that mixture is 3.6 to 1. Also, we actually get a larger total propellant load. I'm unsure if the 1,500 ton figure is possibly for a tanker variant of Starship, but either way, I'll use the larger figure for a worst case scenario for Starship. So the figure we'll go with is a total of 5,200 tons rather than the 4,600 ton figure we were using beforehand. Common Sense Skeptic got the lower figure from the SpaceX website, which appears to be outdated. So I think the FAA figures are closer to reality than what's on SpaceX's website. Also, the FAA number is bigger, so again, worst case scenario. So we know the Raptor engine burns propellants in a 3.6 to 1 mass ratio, and we also know that the total propellant load for a fully stacked Starship and Super Heavy is 5,200 metric tons of propellant. Both of those figures come directly from the FAA. So the mass ratio means that for every 1 kilogram of methane used by a Raptor engine, that engine will require 3.6 kilograms of oxygen. To get the mass of the methane using that ratio, we divide the total propellant weight, 5,200 tons, by the total mixture ratio of 4.6. Which equals 1,130.43 tons of methane. I'll round that up to 130.5 tons. The next step is to figure out how much potential energy is contained in the 1,130.5 tons of methane. The energy density of methane is 55.6 megajoules per kilogram, which means it actually has an energy density 12 times higher than that of TNT. I wonder why they use TNT instead of methane if energy density is all that matters. 1.1305 million kilograms times 55.3 is 62.5 million megajoules, so 62.516 gigajoules. Convert that to kilotons of TNT and you get 14.9. We'll round up to 15 kilotons of TNT worth of potential energy from all the methane contained inside of a Starship Super Heavy stack, which, although many times lower than the number Common Sense Skeptic got, is still very high. But we aren't done yet. 15 kilotons of potential energy is not the same as 15 kilotons of useful or extractable energy. To release the energy of 15 kilotons of TNT, the methane explosion would have to be 100% efficient. That means no energy released through light, no energy released through heat, only energy released through sound energy, which is the shockwave / overpressure event, which is the main thing that makes explosions dangerous and damaging. Now, obviously a 100% efficient explosion is not possible with methane or any chemical process for that matter. The destructive power of the overpressure event is determined by a function of multiple factors. One important factor is detonation velocity. TNT has a detonation velocity of about 7 kilometers per second. Methane gas in an air mixture has a detonation velocity of about 1.8 kilometers per second, and hypothetically, the maximum detonation velocity of a liquid methane and liquid oxygen mixture should be around 6 kilometers per second. However, that detonation velocity is very much affected by how well the oxygen and methane are mixed. In this paper, the expected detonation velocity versus the observed detonation velocity had a difference of almost 1 kilometer per second. This is likely because the calculated values assumed a perfect mixture, which is very difficult to achieve in real life. Even more so when we're talking about the hundreds of liters of reactants that would have to be mixed in the case of Starship to achieve the highest detonation velocity possible. So how do we find out how to convert the potential energy of methane to an observable kilotons worth of TNT yield? Well, according to the beautifully titled Gas Explosion Handbook by Kees van Windingen, yes, I know Starship will use liquid methane, which has a higher detonation velocity than gaseous methane. I will address that, don't worry. The so-called TNT equivalence method has widely been used for gas explosions. The TNT equivalence method applies pressure distance curves for TNT explosions to gas explosions, and the equivalent TNT charge is estimated from the energy content in the exploding gas cloud. For typical hydrocarbons such as methane, etc., the heat of combustion is 10 times higher than the heat reaction of TNT. This means that in a methane explosion, 10 times more potential energy is converted to heat energy than it would be in a TNT explosion. So 10 times the yield factor, let's say 5%, times the mass of the hydrocarbon, in this instance methane, gives us an equivalent TNT charge of 565.25 tons of TNT. Now, that does seem low. Why is that? That is because I'm calculating for 1,130.5 tons of methane gas, which has a detonation velocity slower than liquid methane by a factor, realistically, of about 2.8 times. We'll round that up to 3 for the worst case scenario. Now, I want to be very clear here that this is pure speculation on my part. The yield factor for liquid methane, to my knowledge, is not fully understood. It could be higher, it could be lower. Assuming that detonation velocity is a major factor, I will use that to multiply the yield factor by 3, which, as I mentioned earlier, is how many times faster the detonation velocity of liquid methane is compared with gaseous methane. So 10 times a yield factor of 15% times the mass of the hydrocarbon, 1,130.5 tons, gives us a TNT equivalent charge of 1.69, rounded up is 1.7 kilotons of TNT. My best guess for a fully stacked Starship explosion is a yield of 1.7 kilotons of TNT on the higher end. Why on the higher end? Because the mixture of liquid oxygen and liquid methane matters a lot when you're talking about detonation velocity, and therefore the destructive power of the shockwave. Now, if you're a physicist, please check my numbers and please check my methods. I'm very open to being wrong here, so if you have the credentials, please leave a comment or contact me on Twitter, and if needed, I will post a correction in the description, in a pinned comment, in a tweet, and in my next video. It is also very important to note that this section of the Gas Explosion Handbook finishes by stating, in order to estimate consequences of gas explosions, the geometrical conditions, i.e. confinement and obstructions, have to be taken into account. In the original TNT equivalence method, the geometrical conditions are not taken into account. The results from this type of analysis have therefore hardly any relevance and should in general not be used. In this phase of the video, I will be showing you some of Common Sense Skeptic's more interesting tweets. It is worth mentioning that the person who does the voiceover for the videos is not the only person that has access to the Common Sense Skeptic Twitter account. Supposedly, a few members of their team have access as well. It's worth mentioning that there will be no particular order to the tweets I show, but I will do my best to organize them into specific topics. Topic 1. The environment. Common Sense Skeptic, on the surface level, is quite the advocate for the environment. He is the first to complain about how SpaceX's site at Boca Chica is an atrocity in the middle of a former paradise, and how he cares so much about preventing the destruction of the habitats of endangered species around the Boca Chica site. Where he fails, however, is the consistency of his beliefs. The Common Sense Skeptic Twitter account has made some rather interesting comments on topics relating to environmental issues as a whole, the most damning of which are about the 18-year-old Greta Thunberg. Now, I didn't actually know what he meant by a switch in this context, since we don't use that term in New Zealand, but after looking it up, I discovered that, quote, a switch is a flexible rod which is typically used for corporal punishment. So basically what he is saying here is that Greta Thunberg should be taken into a wooden shed and beaten with a cane. Now, why you would want any child, which she was in this video, let alone a child with autism, to be beaten with a stick is beyond me. Not only does this prove his questionable morals, but it also proves that he has a bizarre disdain for one of the most prominent environmental activists today. Now, while you could argue that maybe he agrees with Thunberg's message, but just not the method in which she's delivering it, I thought that too, that seems fair. But if that's the case, why could he not just say that? Why go so far as to advocate for the beating of an autistic person rather than just saying you disavow their methods of bringing attention to the environment? While that was probably the worst thing he said about Greta Thunberg, he has expressed vitriol towards her on other occasions. Greta Thunberg may be the conscience of her generation, but she doesn't represent it, not even close. Greta should be in school, not scowling at cameras. She's 18, and at 18 you are considered an adult in Europe. She can do whatever the fuck she wants. Or she can stay in school and get an education in something other than on-camera antics. She's a child, not only in age, and most people are tired of her miserable scowl. Here she's become a punchline for her generation. Uneducated child with a platform but no credentials. I assure you she has had more education in science than most of the kids I know of her generation. School isn't some magic box you go through and become a great adult. She's got a crowd, and if that crowd would follow her words, that would definitely be better for our future. Meh, she has a crowd. It's smaller than it was before, and it will eventually lose interest in her. Then what? No education to fall back on? She's selling pastries on the street by the time she's 30. The kid never belonged on the world stage, a novelty that is worn off. This next tweet about the environment is regarding the Insulate Britain protests. The Insulate Britain activist group is a subset of the Extinction Rebellion environmental activist group. Basically, the group wants all houses in Britain to be insulated by the 2030s, and quote, according to The Guardian, the group's demands are in line with consensus among climate scientists and policy experts that home insulation, including when retrofitted, is an environmental priority, saves money to occupants, and is beneficial to the economy. Upon hearing about their protests, well, he posted this. So once again, assuming good faith, instead of disavowing their methods but supporting their message, remember, being a pro-environmental one, he just posts a vitriolic comment. This one's not good either. So here he is responding to a video of Congresswoman Rashida Tlaib, apologies if I'm pronouncing that wrong, confronting the CEO of the Chevron Corporation, one of the largest oil-producing multinational corporations in the world. Now, they have done some very shady shit. Just scratching the surface, quote, there are a total of 70 ongoing cases around the world in 31 countries against Chevron in Africa, Asia, the Middle East, Latin America, and beyond. Of these, only 0.06% of required fines, court judgments, and settlements have been paid, or about $286 million worth. Another $50.5 billion is still pending. In the US alone, there are 13 ongoing litigations against Chevron. As I said, this is barely scratching the surface here, but this article and the report this article is citing are linked in the description. So what does he say to this congresswoman who is confronting one of the largest and most ecologically and environmentally damaging oil corporations in the world? Why are people like this woman allowed to speak? Sew her lips shut and move on. Nothing useful comes out of them anyway. Keeping in mind, this is the same person that goes on about the environmental impacts of the SpaceX site at Boca Chica. The environmental argument about activities at the site is a very important one to have. However, consistency is important too, and you should not argue with people who are arguing in bad faith. And in my opinion, based on those past few examples, Common Sense Skeptic is inconsistent in his argument and is not making the environmental argument in good faith. He seems to only care about the environment when it suits him. Topic 2. Musk hasn't flown on his own rocket. Now, I really hate bringing up Elon Musk. You might have noticed in this video I am purposefully avoiding bringing him up. This is actually the first time since the intro that I've mentioned him in this video, and I will try my best to keep it that way. Anyway, this point is not an uncommon one. Thunderfoot has made it as well. The other two space billionaires have both launched on their rockets. Why hasn't Musk? Common Sense Skeptic uses this fact to make the argument that Musk is a coward or doesn't trust his machine, which therefore means that the Dragon capsule is unsafe for crew. In fact, he goes as far as to say that for the Demo 2 mission, Musk gave the two crew, Bob and Doug, a coin's flip chance of making it back alive. To suggest that NASA would ever let their astronauts fly on a mission that was a coin's flip chance of surviving, especially after the two space shuttle disasters, is insane. The space shuttle had a loss of crew chance, as of NASA's own rating, of 1 in 68. 1 in 68 missions would have led to the loss of crew with the space shuttle. For commercial crew, the acceptable loss of crew chance was decreased by NASA from 1 in 68 to a minimum of 1 in 270. Crew Dragon's loss of crew chance, as confirmed by NASA, is 1 in 276. That sounds just a tad less likely than a coin flip. So If you are going to say that SpaceX is incompetent in this regard, you also have to say that NASA is incompetent, but you won't. If SpaceX's Crew Dragon is unsafe, NASA has to be incompetent for flying NASA astronauts on it. Why won't you call them incompetent? Because they aren't, and you know it. Factually, by NASA's own numbers, Crew Dragon is 4 times less likely to have a loss of crew than the Space Shuttle was. This one is a little bit strange. So, an account posts a picture of a sleeping bee and doesn't credit the photographer that actually took the picture, though the original photographer did have the foresight to put a watermark in the bottom right hand corner of the picture. Awesome macro photography of a sleeping bee. Dominic, please tag and name the photographer. Not naming the photographer could lead to copyright claims against you. Thankfully, the photographer has put his name on the photo, but not all of us do that. If you don't know the name of the photographer, credit the agency/source. As you can clearly see, people aren't reading the name on the photo, and many think you have taken it, which is not fair on the photographer, so please do set the record straight. Citation is in the lower right hand corner. Smarten up. That has him covered just in case, and it's not the OP's responsibility what people read or don't read. I write this response as an amateur wildlife photographer. Had the OP taken the time to name the photographer and tagged them in, he would have been helping the photographer considerably. By not taking the time to do that, there are both potential, legal, and nobody cares. Image is cited. On the contrary, this sort of thing is extremely frowned upon in both the photographic and artistic community. We care about the work we produce, the time taken to produce it, and the copyright, even if you don't. Yeah, free advertising of websites is frowned upon pretty much universally, right? Everyone hates free exposure, except you, apparently, which is why you're harping about this. It's not my photo. Exactly, and nobody cares. Then, the original photographer shows up and says, well, I do. Even though I added a watermark in the photo for exactly this purpose, I want to be credited. Just posting my shot without asking or crediting me is wrong. The ever-charming Common Sense Skeptic replies, exposure you wouldn't otherwise get. Quit whining about it. So already that's not a good look. Reposting others' work without credit is a pretty big issue, and Common Sense Skeptic has taken a less than favorable stance on that issue. But it doesn't end there. This video from Greg Reese is a direct ripoff of our episode debunking Elon Musk. Our frames, our research, our watermark appears on the top right corner at 150 and throughout. See for yourself, point for point script copy, uncredited and needs to be cited. Just found out Greg Reese from Banned Video completely ripped off our debunking Elon Musk episode. Anybody know his Twitter handle so he can give us a proper shout out? What a ripoff artist. Oh no, he didn't credit you, but what about the free exposure you're getting? Your watermark is right there, so that's got you covered. Seriously, smarten up. It's not the OP's responsibility what people read or don't read. Topic 4. The Common Dome. So Common Sense Skeptic has, on multiple occasions, doubled and tripled down on stating that the Common Dome design is an inbuilt point of failure. I already talked about that previously in the video section, so I'll let my best friend in the whole world, Pressure-Fed Astronaut, explain why that argument is dumb.
Morning, everyone. I'm the Pressure-Fed Astronaut, the most credible and sane Starship critic. One of the strangest arguments I've heard against Starship is that it uses a common dome. Common domes are fine. Plenty of launch vehicles use them, and I cannot think of a recent failure that was caused by a common dome. And in fact, a common dome is a great weight-saving technique as well as for thermal management, since liquid oxygen and liquid methane will operate at roughly the same temperatures. While this is a silly argument, it does lead to one of my arguments. Common domes can be a point of failure, sure, but you can engineer them to survive a wide variety of likely loading scenarios for the rocket. The math exists to do it. It's structural. I'm a structures engineer.
Yeah, whatever, no one cares. Moving on.
Topic 5. CGI animations and on-orbit refueling. Until SpaceX perfects in-orbit refueling, these animations need to go away. You're decades away, best case scenario, and with a lot of outside help. Does this mean anything that is years away cannot have animations made of it? It means these animations provide false hope on tech that doesn't exist yet, for the sole purpose of creating empty hype.
While the spacecraft is coasting in its lunar orbit, 2 members of the crew will transfer to the Lunar Excursion Module through the hatch at the connection point between the 2 vehicles. After preparations are completed, the Lunar Excursion Module will separate from the Command and Service Modules, which will remain in lunar orbit. The Lunar Excursion Module will be properly oriented, and its propulsion system will transfer the vehicle into an elliptical orbit suitable for approaching the lunar surface. The vehicle will be reoriented for landing. Then, through a carefully blended combination of manual control and automatic systems operation, the vehicle will be lowered toward the lunar surface.
As the astronauts near the surface, rockets fire to permit the capsule to hover above its landing spot.
These animations were never meant to show exactly what the spacecraft would look like. They were only ever meant to convey the basic look and profile of the mission. It's the exact same with Starship. Things will change from render to render. We actually had 3 different lunar Starship designs come out in under a year. To quote the HBO miniseries From the Earth to the Moon,
"And either way we go, the spacecraft that lands on the moon is going to look like that."
Yes, just like that.
No, doesn't have to.
it's pretty simple. SpaceX is always flirting with bankruptcy. That's why they're constantly having to raise funds and rely on NASA handouts. It's never ending with Musk. What NASA handouts? You mean contracts and development funding? Because NASA is currently doing pretty well out of those handouts. How about the millions for developing in-orbit refueling? That's a good start since nobody else needs it, and millions more just to develop the valves that SpaceX doesn't have yet for that purpose. SpaceX hasn't even worked out the rough details on how the two ships mate. Yes, the government body responsible for space exploration and technological development is giving a company funding for space technological development. Also, nobody else needs in-orbit refueling? Do you have any idea the implications that technology has for space exploration? Are you outside yet? In-orbit refueling is a fool's errand. Fuel depots in orbit are pure nonsense. It makes far more sense to develop machines that can launch and break orbit with everything they need already on board. And with that, we're done. SpaceX is not the only company investing in on-orbit refueling of cryogenic propellants. ULA has done extensive research into this topic, and the concept dates back to the Apollo era. Topic 6. Lunar Propulsive Landing. This is a classic Common Sense Skeptic moment. A while ago, a company by the name of Moonmark planned to race 2 small rovers on the moon. They would hitch a ride on Intuitive Machines' Nova C lander, which itself uses the Falcon 9 as a launch vehicle. Remember when Musk made this claim and people believed him? 5 days to make good, buddy. That article's headline seems to be clickbait. I read the press release and browsed the websites. This seems to be Moonmark's project, using Intuitive's Moon rover technology and SpaceX as the launch provider only. Moonmark was still talking about this during some podcast this past July, but I couldn't find the content. If you find out how they planned on landing a Dragon capsule on the moon and deploying 2 cars afterwards, please share. So even though this gentleman explained it to him, he thinks that SpaceX themselves are for some reason going to use their Dragon capsule as a lunar lander. I know you're being facetious, but SpaceX is supposed to be launching 3 of the Intuitive Machines rovers to the moon. This is true. Intuitive Machines has been contracted by NASA to build and launch 3 Nova C landers to deliver various NASA and commercial payloads to the surface of the moon. This was done under the Commercial Lunar Payload Services program. Again, Common Sense Skeptic fails to realize that the only role SpaceX has in this mission is the launch provider. They are not using a Dragon capsule to land on the moon. Once again, Robert explains that the Intuitive Machines Nova C lander will use propulsion to land. Falcon 9 is just taking them to the moon's orbit. The Dragon capsule is not in the picture whatsoever. To which he replies, propulsive landing in the lunar regolith. Good luck. I don't need to explain to you why that statement is dumb. I think you can figure that out for yourself. Anyone with common sense would know that propulsive landing on lunar regolith is basically the only way to land on the moon. Except none of Musk's machines have legs to hold them off the surface. Firstly, yes, they do. Secondly, the Nova C lander is not a SpaceX lander. It is a payload of a SpaceX rocket. SpaceX did not design the lander, they are just launching it. Lunar Starship has legs, you stubborn nincompoop. Sure it does. Depends on which imaginary CGI you're looking at. Nice looking legs in this one. You all realize Musk never gets us to the moon, right? You're not any false illusions there, are you? This CGI will never be a real photo. So yeah, he says that and shows 2 very outdated renders of a lunar Starship. Mate, neither of those renders are going to the moon. This conversation isn't about Starship, we're talking about Intuitive Machines lander. Also, here's proof of propulsive landing on the moon. Note the legs. Yeah, note the legs. Note the legs! What he does next is quite interesting. He says here that there is a big difference between landing on the lunar regolith and in the regolith. How you would land in the regolith is beyond me. Maybe he thinks that the engine on the Nova C lander would make a crater in the lunar regolith that is larger than the legs could handle, but doing that in lunar regolith is actually pretty hard. Like, the Nova C lander is 3 meters tall and 2 meters wide. That is tiny compared with the Apollo lunar module. And the lunar module is the biggest thing we have landed on the moon so far, and its descent engine, which is much bigger and more powerful than the Nova C's descent engine, barely scratched the lunar surface. So I genuinely have no idea what he's on about here. Topic 7. Obsession with Tesla stock. Common Sense Skeptic definitely has an obsession with Tesla stock. His feed is flush with predictions, comments, and analysis of the stock. Interestingly, some of his tweets have alluded to him shorting Tesla stock. I cannot say for sure if he is a short seller since I don't know. What I can say is that it is very suspicious that he follows Tesla stock so closely. If he wasn't invested in some way, why would he follow it the way he does? Topic 8. Asperger's. Semi-recently, Elon Musk made the statement that he has Asperger's. I am not going to speak to whether or not that is true. There's no real way to know for sure without seeing a diagnosis. On the topic of diagnosis, Common Sense Skeptic replied to a person with Asperger's, more bullshit. The claim he made was Asperger's, which is not diagnosable in adults, and there's no mention of it in any previous statement, article, or biography from his childhood. Pure horse crap that you believed. Just because there is no set in stone diagnostic criteria doesn't mean that it isn't diagnosable. Topic 9. Linking sources. One thing Common Sense Skeptic likes to do, or likes not to do, is linking sources. Bullshit Exposed on Twitter has a great 45-second video that perfectly demonstrates how this clown is bought and paid for by Tesla. I suppose a link was too difficult? Does your mother pre-chew your food? Go look for it. That's charming. My friend, if you make a claim, it is your responsibility to cite your source. In our case, we cite published sources of information. In your case, it's a buddy of a buddy who knows someone who might have talked to Tim. Nothing like what was contracted at all. The system was supposed to use 18-person autonomous shuttles. Monkey Pong was done literally 20 years ago. You realize that you were demonstrating yourself to be exactly the type of scientific illiterate Musk relies on to scam people. Should be easy to show then. I mean, both the approved contract and Monkey Pong as good as the one from Neuralink but being done 20 years ago. Go find it, or does your mother pre-chew your food for you still? Those were your claims. Then disprove them. Those facts are out there waiting for you to find them. Do the work, lazy piece of shit. Topic 9. Inspiration 4. Common Sense Skeptic has made some very interesting comments about the Inspiration 4 cupola dome. Let's have a look at a few of them. Perseids was a meteor shower that was occurring at the time Inspiration 4 was launching. The chances of Perseids hitting the dome are astronomically small. Has acrylic ever been used on any other orbital craft? Yes, acrylic has been used on spacecraft before. Glass is very good at dealing with high temperatures, but is also very heavy. The Crew Dragon capsule, for example, uses acrylic windows. This structure is substandard to the ISS cupola. Yes, it is. Do you know why? This one has to last for decades. This one has to last for 3 days. Is there a rescue plan in place for retrieving them if the capsule fails? No, that isn't how spaceflight works. There is never a rescue plan if the spacecraft fails. This is an argument that was made after the Columbia disaster. There were a lot of talks about if the crew could have been rescued, and the answer is sadly no. Topic 10. Pure conspiracy. Would any skeptic YouTuber be complete without just a few conspiracy theories sprinkled in? Let's look at a few that Common Sense Skeptic has peddled. SpaceX absolutely had a revenue stream through both government and private launches they received contracts for, like the Facebook satellite that blew up on the pad. Or did it? Strange how Musk came up with Starlink right around the same time he blew up Zuckerberg's baby that was going to deliver free internet into the heart of Africa. The only SpaceX rocket to have blown up on the pad was the infamous Amos 6 pad anomaly. Amos 6 was an Israeli communications satellite, not a Facebook one. Facebook and a company called Eutelsat leased out the Ka-band spot beam broadband capacity. The reason for this was to provide satellite internet to some African nations. It would not be free internet, it was part of Facebook's Internet.org partnership that, quote, plans to bring affordable access to selected internet services to less developed countries by increasing efficiency and facilitating the development of new business models around the provision of internet access. This isn't complete internet access either. The service has been criticized for violating violating net neutrality and, quote, by handpicking internet services that are included for discriminating against companies not in the list, including Facebook's rivals. So to say that Amos 6 was a Facebook satellite that was going to deliver free internet to the heart of Africa is factually not true on multiple levels. It's not a Facebook satellite and it wasn't going to deliver free internet to Africa. The anomaly was caused by an issue on the composite overwrapped pressure vessels, an issue that had never been seen before. The explosion grounded every Falcon 9 for 2 months and severely damaged SLC-40. It took 15 months between the explosion and the next launch from SLC-40 due to repairs. If SpaceX was so concerned about the satellite, why could they not have blown it up in flight like CRS-7 so that it didn't completely wipe out SLC-40? He is suggesting here that Elon Musk ordered the destruction of an Israeli communications satellite, which Facebook had a 5-year lease on some of the bandwidth, resulting in the loss of a vehicle, the loss of the payload, the grounding of the Falcon 9 vehicle, the severe destruction of SLC-40, the delay of human rating Falcon 9, the faking of a report into the cause of the failure, lying to NASA with said fake report, and then launching the replacement Amos 17 satellite without charge to the customer. That mission, by the way, expended a Falcon 9 Block 5 booster anyway, so they actually ended up losing 2 Falcon 9 boosters. If you actually think that is the case, I don't know what to tell you. No matter how much you've looked into Musk's destruction of Boca Chica, there is more to learn in this video. We encourage people to take a deep look into Musk's plans for destroying this ecologically unique area. And it's all for nothing. For rockets, this location sucks. If not for rockets, then there must be a strategic reason for that location. A clue. So yeah, he is suggesting that the Boca Chica launch site is actually a cover for a drug smuggling operation, and that SpaceX is working with drug cartels to cover drug smuggling. Now, of course he uses a Fox News article, but the article doesn't actually say whether or not the SpaceX site is encouraging or deterring drug smugglers. It mainly talks about how difficult it is for the DEA and border security to monitor this area due to the marshland type landscape. Quote, after the drugs have been crossed over, they will walk all night to get it across through here, and it even passes through SpaceX. I'm guessing he means SpaceX property, making its way all the way to the Bay and South Padre Island, Yami asks. Elon Musk's SpaceX facility has some of the strictest security this state has seen, but this is not enough to deter smugglers. In this screenshot, he is suggesting that the person who wrote this written re-evaluation was bribed by SpaceX with a new Tesla to give SpaceX permission to launch Starship. The reason the FAA is currently working on a new environmental impact statement is basically because SpaceX wants to launch full-scale orbital flights from the Boca Chica launch site, which, as you can see, are not covered by the written re-evaluation. Here he is showing support for a conspiracy theorist that thinks the Falcon Heavy test flight was fake and that they didn't launch a car into space, so that's lovely. Common Sense Skeptic got into a bit of an argument with Scott Manley on Twitter. He deleted one of his tweets and then said that he didn't delete any tweets, but if he did, it was because there was a spelling mistake in it. But there wasn't a spelling mistake in it. He was just wrong. Boeing's proposal didn't even make it into the top 3 HLS proposals. The Boeing proposal certainly couldn't get back to Earth, let alone land on it. Topic 12. Religion. This is a lovely non-controversial conversation to have. Now, this one is a bit long, so please bear with me. So this thread begins with a tweet about Tesla delivery numbers allegedly being low. A commenter replies, I would love to see a debate with the topic Elon Musk is a fraud, with Thunderfoot and Common Sense Skeptic for the affirmative. Will realistically not happen at I2², but why not find 2 high-profile Musk proponents and make it happen here on YouTube? Another commenter joins, seriously, nothing Musk announced that would actually be groundbreaking has ever happened. Hyperloop will never happen, like absolutely clear. The biggest fraud told to the public, and it's not even a new fraud. It is like, in the best case, you could show that a bit of his work is no fraud. Musk is like some guy who likes sci-fi and dreams out loud about cool things to invent. He does none of the inventing himself though, and he is clueless about timelines and how hard it is. Humanoid robot prototype in 2022? That's so insanely ludicrous that I'm speechless. And yet we have millions of people around the globe, if not billions, who fall for him. We are so fucking doomed. Climate change is not even our biggest problem, it's just a symptom. Totally agree, the root of our problem is that people have lost the sense of meaning, and the feeling of usefulness that real struggle gives. We are too well off, and important institutions, religion, etc., have been rejected, so people turn to cults like Musk for nothing. Religion is not really part of the solution here. Yes and no. 95% of people are followers. They do what they're told by the other 5%. You learn this in crisis management and leadership training. Those people at their core need something to follow. We were all better off when that need was filled by religion. People like to crap on religion, but consider, the church used to be the center of all charity, education, and medicine. They operated all of this using 10% tithes corrected from their parishioners. Their core beliefs of religion, family, duty, faith, charity, are now sorely lacking. The commandments might not have been written in stone and delivered by God, but there's no disputing that they are good rules to live by. In fact, our judicial system is still based on them. As belief stopped believing in God, they start believing in false prophets, and Elon Musk is the very definition of a false prophet, with his legions of dedicated, scientifically illiterate muskrats. Can you appreciate how fixated and obsessed CSS is with his Musk bad crusade to deem religion desirable? Like, it's starting to sound like insanity at this point. Religion is not desirable per se, we just haven't found the useful alternative yet. That's why our world is in this sorry mess. When I dropped my childhood religion, I felt like I had a hole inside of me. I've replaced that with a sense of spirituality I get from being a part of the universe, being made of stardust. We need more public discussion about purpose and meaning. The hard truth is that there is no real purpose. We exist and continue to exist, but since we evolved consciousness/self-awareness, we also crave some way to give meaning to our existence, which is part of being human. Fortunately, there are ways to fill in that hole without superstition. Please explain how. By living. You don't need an imaginary friend in your life, and there are alternatives to spiritual counseling. They are called psychologists. Plus, friends and family as support. To think that superstition is a necessity is quite narrow-minded. Most of religion isn't superstition. It's community, charity, support, and rules to live by, which is pretty much how people should be living anyway. Do unto other, don't steal, don't covet, don't murder. You say you go to your friends for support. How many friends do you have? People stuck in social media have lots of acquaintances, but no actual friends. Someone you would trust with your money, your wife, your life, thick and thin, any time of day. And family. What sense of family remains in the world when divorces outnumber nuclear families? I'm going to pause here because I find this one particularly ironic. I've been on Twitter since March 2021, only 1 month after Common Sense Skeptic joined. As of writing this, Common Sense Skeptic has almost 10,000 tweets, yet I only joined 1 month after him, have just under 4,000 tweets. The argument could be made that the Twitter account isn't just run by one person. That also doesn't account for his Reddit posts or his Facebook posts, neither of which are platforms that I personally use. I do have a Reddit account, but I only use it for advertising. The Common Sense Skeptic Reddit account, on the other hand, is used quite frequently, so something glass houses. Moving on. The small minds that crap on religion have no idea the positive roles it has played in our lives. The problem isn't the good that religion does, it's the bad that it does. Unmoving or slow-moving social changes causing significant psychological harm are just one example. Not everything needs changing. Most of the changes in recent history have certainly not been positive. I would love to know which changes he's referring to here specifically. What about people being allowed and encouraged more and more to admit their natural sexual attractions? Do you see that as a negative? Love who you love, but don't expect special treatment for it. The logical solution is always going to be equal rights, but what everyone is after these days is special considerations, and when the minorities are spitting in the face of the majority, that's not going to end well. I don't know what special considerations he thinks we're asking for, but I will say as a queer trans woman, in most states of the United States, I could legally be fired purely based on my gender identity, and there is nothing I could do about that. That is discrimination, and that is still legal. Asking for rights and protections is not asking for special treatment. Asking to be treated and respected as a human is not asking for special treatment. And again, religion has not played a fantastic role in my life. This whole conversation has basically outed Common Sense Skeptic as some form of traditionalist boomer. I would love to see him respond to me without being disgustingly bigoted and transphobic. After that slow-paced slog, I would like to have a bit of a speed round. I call it Topic 13, Lies and General Stupidity. The Blue Origin lander that lands back on Earth. Old man yells at whistle. The time he said that an HLS Starship didn't have solar arrays when in fact it did. He tried to save face by saying that there weren't enough solar panels. When someone actually did the math for it, he blocked them. You can still read the Twitter thread, by the way. Link is in the description. The time someone had an absolutely horrific head-on collision with a van and just barely survived. Someone shared pictures of the mangled Tesla Model 3 that she was in and linked her GoFundMe to help pay for her medical bills. Common Sense Skeptic replied, "Saved her life? Looks like that car tried to kill her." ADAS not working worth a shit. I'm just going to read some information about the condition that Jenny was in after her crash. Her injuries are severe and will alter her life forever. In the last 3 days, she has undergone surgeries to remove her ruptured spleen, repair multiple breaks in both of her legs, pelvic bone and shattered foot, a tracheostomy procedure, and facial reconstruction of her jaw, nose and cheekbones. It was a miracle she survived. By the way, the driver of the van that hit her head on wasn't so lucky. Common Sense Skeptic uses this tragedy not to wish Jenny a speedy recovery or share her GoFundMe, but to say shit like this for no other reason than she was driving a car he doesn't like. How he insists on capitalizing the middle letter S in the word Starship. Starship will never make it to orbit. We always assumed Starship could make it to orbit. The time he got his ass handed to him by Lab Padre on the topic of seismic sensors at the Boca Chica launch site. Old man forgets water trucks exist. The time he suggested nuking Iran. The classic, why is Colombia operating in the Pacific? That one time he thought the Apogee Report was a real news outlet. That's equivalent to thinking that The Onion is a real news agency. Starlink. Notice how he often capitalizes the L in the word Starlink, which is ironic considering how he usually refuses to take the L. Anyway, he insists that SpaceX is going to launch 42,000 Starlink satellites, even though they currently only filed for the approval of 12,000 satellites. The 42,000 figure comes from combining the number of Gen 1 satellites, 12,000, and the number of Gen 2 satellites, which will be 30,000. It is very important to note that Gen 2 is a replacement for Gen 1. The constellations will not exist at the same time. The time he suggested that the reason Russia pulled out of the ISS is because of SpaceX. Even though SpaceX has been delivering cargo since 2012, they have apparently only now decided that they want out. The time he didn't realize that the term interplanetary didn't necessarily mean going to another planet. Surface level understanding once again. That wonderful moment where he joked about a Tesla building and the recent Colorado wildfires that left hundreds of people without a home. Classy. Topic 14. Pain. So, as I was writing this script, he outed himself as a transphobe. Am I surprised? No. Am I still disappointed? Yes. Not just because this affects me directly, it is an extremely hateful opinion to hold, and the space community is full of people who know how otherism feels, who know how bullying feels, and joking at the expense of any oppressed minority group is not a good look. If this is a topic you need convincing on, I am not going to have that debate on this channel. All I'm going to do is direct you to an education resource and a few other YouTubers. This brings me to the final topic on his Twitter. Topic 15. Ad hominem. As with all the ad hominem responses, it's very telling that people can't argue our facts, so they attack the channel. It's pretty typical muskrat behavior. You would never make an ad hominem argument though, would you? Hold your head under the water until the bubbles stop. You clowns only think you're burning us. History is going to bear out a completely different outcome. Idiots, like yourself, kick and scream against facts. It's pretty pathetic when you represent the level of diminished intelligence of your community. Facts hurt your bum, do they? Poor little snowflake you are. Maybe you'd like Rocket Jesus to apply some ointment. Ural86 and his boyfriend Little Blue Balls. And don't flatter yourself or your date. The post was brought to our attention. Neither of you is worth a shit, grand scheme of things. So are we done pretending that House isn't a complete sycophant, not wasting our time on knuckle draggers? Go find it, or does your mother pre-chew your food for you still? Do the work, lazy piece of shit. You're just another muskrat simp that believes every word out of his stammering mouth. That makes you an idiot, worshipping a moron. And would you look at that, the pissant squad with no life of their own are back to Raine on everybody's day. What a fucking surprise. Wouldn't it be amazing if they were contributing something other than drool to a conversation? Like all other muskrats, try being original and thinking for yourself. It's very freeing. That little twat needs a comeuppance every fucking time. Bunch of little twats. Yep, mom's still feeding you in the basement. You've got to be pretty pathetic to still be living all the whiny bitch muskrats. This piece of shit would be useless. Fox for the other Anybody who's been around for it's time for you to fuck off. They tend to be the dimmer bulbs on the string. And those are just the ones that I was sent. I'm sure there are countless other examples. A few months ago now, a person by the name of LCS Big Mike did a live stream in which Common Sense Skeptic was a guest. They discussed many different topics, but mainly focused on the HLS Starship. The original live stream was streamed on Twitch, but Mike had issues in recording/saving the VOD. However, I screen recorded the whole thing in case something like that were to happen. To my knowledge, I have the only copy of the VOD in existence. Once I have uploaded the raw VOD, I'll put a link to it in the description. I do want to apologize for the audio quality of the stream. stream, Common Sense Skeptic's microphone was very quiet and Mike's was picking up a lot of background noise. Now the live stream was about 3 hours long, so there's no way I could cover every topic. I'm just going to cover the interesting ones. I actually did a live stream of us rewatching the screen recording of the original stream.
I bury the ass end of this thing into the regolith. You do eventually have to take off from the surface, even if it survives the landing.
Even if?
Which,
You could look at the crush legs there right now up on your screen. If you're landing in the equivalent of talcum.
Oh, dude. Okay, so he was saying that he thinks they're going to use these legs.
Yes, Common Sense Skeptic just suggested that SpaceX was going to use the prototype crush legs to land on the moon in the HLS version of Starship. Surface level understanding.
No, I love when they talk about, like, some of their arguments are basically like implying that we can't land on the moon at all, despite the fact that we've done it 5 times before.
The talcum powder argument, it behaves very differently to talcum powder. Might have the consistency of it, but it, as a whole, it behaves differently. That's why on the Apollo landers, they overbuilt the shock-absorbing crush cores because they expected the lunar regolith to behave differently. It actually absorbed more shock.
Everyday Astronaut actually has a very interesting video that talks about this exact point.
Down by cable crane, which is not a smart move.
Okay, let's carry on.
And through the center of gravity. Depending on what your load is, you're going to be taking the center of gravity outside the ship, depending on the weight of the load. And trying to get it down in, in freezing conditions, right? Open space pretty much on the moon.
Did you say freezing conditions?
Depending on the weight of the load. And trying to get it down in, in freezing conditions.
Yes, he said okay.
Temperatures on the moon in sunlight are boiling hot, not freezing. I don't know how he got that wrong.
Well, if you're in shadow, then yes. If you're in sun, it's boiling hot. That's why the suits were white.
Space pretty much on the moon. And I don't know if you ever tried wrapping up an extension cord in the winter. Doesn't work well. Wire cables don't work well in the cold.
What?
Extension cords become stiff in freezing temperatures because the outer insulation freezes, not because the actual metal cable itself is cold. Obviously, this isn't an issue in this situation because there would be no insulation on the cable to freeze and stiffen. That's why you see steel cables in use on ski lifts, for example.
Just so much of it is taken at face value and none of it's questioned, and we got tired of going along with it. I mean, most of the guys here were Musk fans.
Oh.
And then we'd sit around Christmas, Thanksgiving, whatever, with a couple beers in us. Like.
Oh, okay. Well, that actually might explain it.
I've had him sober. I don't want to know what he sounds like.
Oh my! Could you fucking imagine? Racist uncle.
For the most part, want their spot back. I mean, Boca Chica for a launch site for orbital entry is a pathetic location. You've got a 4-degree window between the bottom of Florida and the top of Cuba to get those things into orbit.
I've heard that argument before.
What he is insinuating here is that Boca Chica is a poor launch site because he thinks they will have less freedom in launch azimuths. This is only true for the first dozen or so successful launches. Once they have proven the vehicle reliable, Starship would likely be able to fly over land earlier in its trajectory. This was also the case with Falcon 9. Recently, a Falcon 9 carrying Starlink satellites launched from the Cape and flew straight over the Dominican Republic. Even if this wasn't already proven not to be an issue, the low Earth orbit capacity of Starship is so large that doglegs will not impact performance too much.
There was also a couple of years ago it was an underreported and undetermined cause of a big green turtle, and those are the most critically endangered. Those are the most rare ones. There's a big kill-off in that area a couple years back that nobody could explain, and it wasn't a cold stun.
Right.
So what is he insinuating here when he brings this event up? I'm very curious to know, because I hope he isn't suggesting that SpaceX had anything at all to do with that, because there is no evidence at all to suggest that is the case. That is pure speculation and pure conspiracy on his part.
Point is, they did do testing with the various landing pads, different landing angles, and as long as the landing base is wide enough, the testing did show that they could safely dig into it. And as my slideshow will even show, they actually do have the lunar surface isn't as dusty as it's made out to be. For example, let's go with this one.
Word what you just said there, because you're talking about a wide-based vehicle being able to settle into the regolith, right?
Yeah.
This is not a wide-based vehicle. This is a cigar tube.
Dude. Okay. The base of the vehicle doesn't matter anywhere near as much as the base of the legs.
Which, it's a cigar tube, but we do have some images that show that it does.
That is such a weird argument.
At least the more recent photos do show that it has wider.
Yeah, like, what the fuck? What's he talking about? Look how wide the leg base is in this render. What?
Legs. It's not as thin as. Yeah.
You have photos. You have CGI, like the one.
Oh, for fuck's sake! Ah! What? It's not photos. It's CGI renders. Yes, it's a concept. It's not built yet.
What's up on the screen right now? That's not real.
But there's nothing stopping it from being.
Yeah, exactly. No, Mike is completely right.
I mean, I'm not trying to excuse it, but there's nothing stopping that.
Right now, looking at that photo, that those legs have nowhere to fold into. Why? Because that's where the engines are.
That is a good point. In chat, Falcon 9 landing legs fold flat against the rocket. The shock absorbers are completely contained in the shape of the actual legs.
Backwards, they could be telescopic. I mean, that's how the Falcon 9 works, is that the Falcon 9 has telescopic landing legs, is that when it folds back, it extends into itself.
It's like, you got the legs coming out of there. Great. You know what else I've seen coming out of there? Giant solar panels.
Notice how he changes the topic once the general consensus is made that there are ways to engineer landing legs to fold flat against a cylindrical rocket. Even if the landing legs don't fold completely flat, there is still room in the aft skirt of Starship. Notice how the large origami style solar panels are not present in the HLS render, and have never been present in any HLS Starship render.
I don't think so. Hang on, I'm going to play.
Open up those vacuum raptors, and what's going to happen to them? They're going to get
okay. One more go.
6 feet off of the regolith, something like that. Open up those vacuum raptors, and what's going to happen to them? They're going to get chewed to shit.
Ah! He thinks that they're going to lift off with the RVAX? What?
Even since earlier HLS renders, landing engines positioned above the main propellant tanks were part of the design. This isn't just in the renders either.
Shall I read it again?
Okay, I think I understand what the question is for my part. I'll go ahead and go first.
Okay.
I think the question's about for the terminal descent of Starship a few tens of meters before we touch down on the lunar surface. We actually use a high thrust RCS system so that we don't impinge on the surface of the moon with the high thrust Raptor engines. So I think that's what the person is asking about. The thrusters that are planned there have a lot of heritage in the actual Raptor design itself. It uses the same methane and oxygen propellants as Raptor. So there's a lot of commonality there, and we're going to be we're going to be ramping up some very rapid testing activities coming up here in the coming year. So I think you'll be hearing more about that as time goes on.
The person talking in that video is a man by the name of Nick Cummings. He is the Director of Advanced Development for Civil Space at SpaceX. This video is 1.5 years old. It's been common knowledge for quite some time now. The fact Common Sense Skeptic and his team of doctors, scientists, and PhDs haven't figured that out is quite telling.
Does he not realize that they know that the RVAX would be fucked if they were turned on close to the lunar regolith? And that they've thought about that, and that is why they have lunar engines. Yes, I'll go back. Have a listen.
Hold on a fucking minute. So he's saying that a feature they've already ruled out as being a thing is gonna be bad. Fucking
This is the most recent. That's why I specifically chose this image, is that because it's the most recent official.
6 feet off of the regolith, something like that. Open up those vacuum raptors, and what's going to happen to them? They're going to get chewed to shit.
What do I say? What do I say to that? He doesn't know what he's talking about. That's ridiculous.
I keep it 50-50 if it's actually going to be higher up.
They plan on landing this thing.
What?
I see them having enough energy to get it back off of the surface.
Oh, dude.
This is for the Apollo lunar module. Quote, on the early missions, thrust to weight would have been about 1.76 in early descent, and as the descent fuel was consumed, gradually increased to about 3.63 at engine shutdown. On the later missions, thrust to weight would have been about 1.63 at the start of descent and about 3.28 at shutdown. That being said, the descent engine throttled down enough so that the thrust to weight ratio is around 1 so that it could hover right before landing. For landing engines, the thrust to weight ratio has to be high. If the thrust to weight ratio is high, that means there is enough thrust to lift off the lunar surface with the landing engines.
Ready to go up, even if the ship itself was perfect, which nobody here is agreeing to. You need a deluge system. The deluge system needs a desalinization plant. Desalinization plant needs a power plant.
Yeah, this is a weird argument as well. They're talking about the deluge system. Because, yeah, like I said in chat here in a second.
A gas line.
Idiot forgets water trucks exist.
The pipeline.
And I'm hearing others are mentioning that they could use tankers to bring in water. So
you can try it.
I mean,
yeah, you can try
there's
it.
nothing stopping such a method.
Do you see a water tower there big enough to handle that type of load?
Yes, actually. Yes, it's part of the GSE equipment.
There's no structure at that site big enough to hold that amount of water.
Most of the water motors are very energy efficient. If you can, if you know what you're doing, you can make them very energy efficient. Plus, I would like just to point out something that you may have missed is that being at the South Pole, the sun will also end up.
Oh, okay. I hate this bit. Basically, you'll have to listen closely because his audio is really shit. This bit is very, very uncomfortable. This is where Common Sense Skeptic asks for me to be removed from the chat. So I think I will just play it.
The sun will also end up.
Ask a ready here.
Say again.
Astro Kiwi. Yeah. Kiwi. Got go.
Isn't the radio?
Good and for Twitch. This is over. Tired of looking at him.
I'm leaving the chat alone. But what I was just saying is, I'm not.
Then we're done.
What?
Yeah. Boot him or I'm done. Looking at him.
Let the chat decide that one because whatever.
What the actual fuck? Hold up.
So.
Oh my
so
God.
he threatened to leave if I didn't leave chat. So I did the epic gamer move of still being there but not typing. But I actually do start typing again later in chat.
This falls into the same problem of the other two landers because although they have big solar panels, is that enough? Or are we just making hypothetical excuses to say those solar panels are big enough?
We're basing the.
Yeah, okay, so Common Sense Skeptic didn't do the math for the solar panels. I might have an old screenshot. When one of the first renders came out for the HLS, he was like, oh, where are the radiators? Where are the solar panels? Don't they think of the basics? And this was one of the renders that showed the solar panels right fucking there. Here we go. So yeah,
Solar rays, cooling panels, nobody actually thinks
dun, dun, da, 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 da.
Panels could be an overcome issue is that, especially going back in history, I mean, the lunar module wasn't stopped by a lack of solar panels. It used a fixed power supply with the fuel cells on board and batteries.
Apollo didn't go to the moon with the idea of colonizing it.
What? That's not why Artemis is going to the moon. What? Yeah, they want to set up a base. They don't want to colonize it. Like, a lunar base is the end game of Artemis.
Again, just speaking to if these landers could work, Lockheed, the national team was only slated for what, a couple of weeks, which is already longer than Apollo, but it's, no one's talking about colonization or anything right now except for Musk, which I don't take seriously.
And when it comes right down to it, that's kind of the whole premise here, is that we've stopped taking anything he's saying seriously.
Which is, even if we disregard Elon Musk, there's still SpaceX Official, which is a company of thousands and millions of very capable people.
The lady in charge there,
Thousands and millions.
She had some credibility when she went there. Her husband works for.
Oh, she's credible because her husband
JPL.
works for JPL. Okay. That's yeah. Okay, listen. Shh. I'll turn it up.
There, when Shotwell, he's just become she had some credibility when she went there. Her husband works for JPL. He's got obviously some history with the space race as well. But
that is so fucking sexist. That's so old-fashioned. Oh well, she's credible because her husband works for JPL. Fuck you.
That's right, everyone. Gwynne Shotwell is only credible because her husband worked at JPL. Not because she has a master's degree or has been working in the aerospace industry for more than 30 years, but because her husband worked at JPL. That is textbook misogyny.
If, you can choose to answer this one or not, but someone's bringing up that you mentioned Blue Origin lander returning to Earth.
That was a misprint. That was going into the conversation, not completely 100% aware. I personally, because I'm more focused on the floor plans and whatnot of Starship. That's kind of where my focus is. But, under the impression that what launched from the moon was going to be what landed back at Earth,
Yep. So he thought the Blue Origin lander proposal would launch to the moon, land on the moon, and then come back and land on Earth. So instead of researching that, he just said that that was what was going to happen, said it as gospel, and then made no correction. I'm pretty sure this is the only correction he's ever made on this stream that I think I'm the only one that has a copy of.
Ridiculous. It opens up like a Bond. It's actually straight out of Moonraker. Where the nose opens up like a Pac-Man.
They changed that. They changed the door design. It opens more like a shuttle payload bay now.
From a single hinge point on a rounded surface, where with shuttle, for example, it was a rounded surface across the top, but the hinge points were down the side and they were level with each other.
What was that?
Neutron does. I'm also for the nose open up sort of thing. Neutron does that now. Similar to Moonraker.
Yes, but he likes Neutron.
Yes.
There's no clear exit out of what they're...
Anyway, this is all moot because they did change the payload door design to being like the shuttle. So there is a clear exit out.
It's going to be a satellite deploying Starship. I see what sci-fi is saying here. If they go to a shuttle style door, now you're going more and more towards turning this into a shuttle, which is what...
No, you're not. Is not comparable to the shuttle.
Musk should have done with this damn thing.
He should have made it into a shuttle. What?
In the first place, he should have taken an old shuttle, broken it down, new tech.
What? Does he really believe
this? That thing was a workhorse. Okay, it's a little bit old compared to...
He wants to put it on Mars. Why would they use a shuttle?
To the technology of the day, you upgrade the computers, you upgrade the hydraulics. Then you take those SRBs and you replace them with something like what's sending Falcon Heavy up.
I'm very confused. He's suggesting a modified shuttle, and then replacing the SRBs with liquid fuel boosters like Falcon 9.
There's no guarantee. Whereas now NASA has funding not just for one lander, but larger amount of money for two.
NASA used to, excuse me, used to always have a backup plan. There's no backup plan with HLS.
I don't know what he means by that. When he says NASA always used to have a backup plan, there's no backup plan for HLS. There was no second LEM. Like, they didn't have a different LEM that they could use. It was just one. There was no backup plan for that. I really don't know what he means by that.
That's a very odd statement.
Yeah.
If HLS fails, then nobody else is working on it.
It's the same. It's the same with the original LEM.
Right now, right? Or if they are, we don't hear about it anymore. If Blue Origin and National Team and Dynetics is still working on their respective machines, I don't think we've heard anything about that since they chose, right?
If I remember correctly, Blue Origin is still quote unquote working on it, but again, that's Blue Origin quote unquote.
So that wraps up the final phase of this video. If you'd like to watch the full uncut VOD of LCS Mike's stream with Common Sense Skeptic, the link is in the description, and I will also add a pop-up card in the top right hand corner. If you've made it this far, thank you very much for watching, and I hope you've enjoyed it. Please consider subscribing if you haven't already. Only a small percentage of my viewers are subscribed, and I also have a Patreon if you really like me. My Patreon is completely optional, by the way. All of my content will always be free. Patreon is only if you want to show extra support, and I only have one tier because I don't want people spending ludicrous amounts of money on me. To conclude, from what I have covered in this video, Common Sense Skeptic has proven time and time again that he is a bad source of information for space-related topics. His arguments come from a place of bad faith. He hardly ever corrects himself. When he does, it's in a fashion where not many people can see it. He has very problematic views on social issues. He is a misogynist. He is a transphobe. But the question remains, should we, as a community, indulge this person in using their platform to spread hatred and using their platform to spread misinformation? That is not a decision that I can make for you. You yourself must decide whether or not to give your views, your subscription, your money, or your time to that channel. For myself, I think I've made this video about as thorough as I can. I haven't covered everything, and I probably won't cover Common Sense Skeptic again unless he does something even worse than he has already done. That being said, I may do live streams in the future where I react to some of his videos. To Common Sense Skeptic, I know you will probably watch this at one point or another, so as long as you're respectful, I could be interested in a dialogue. Anyway, you keep doing you, but please don't claim to be the authority on things you don't know enough about. And it has been made painfully clear that you don't know all that much about space or spaceflight. Let us do us, and you can keep doing you. Massive thanks to those who helped me put this video together. You know who you are, and I really appreciate it. I'll see you all next time.